Okay, my class isn't here, so I guess I'm just going to do this on my own. Alright, so what we're going to do now, what this one's going to be about, is determining whether a graph is continuous or not. So you can see that we've got points that are filled in here. We got a point right here where it's open, and then we have like a vertical asymptote here too. So we have to see, like, is the graph continuous or not. We have certain ways to figure that out. So first thing I'm going to do is I'm going to look at this point. So that's going to be at the point x is equal to -6. So what I'm going to do to figure out whether this thing is actually continuous or not, I'm going to do it up here, I'm going to do that here. We've got different rules, so it has to follow these 3 rules. Here's the first one. Does it approach the same number from both sides? So that's number 1. So this one, so let's say the limit, I'm going to do this way. I'm just going to show you first. So if we go with the limit of f of x, and that's just this graph, right? That's all we're saying. We don't actually need the numbers when we're doing these. As x approaches -6, but the new thing I'm going to add in here is if you put a little negative symbol up there, that means from the left. So what that means is that as we approach this way from the left, what's the limit? And in this case, as we approach it from the left, it's going to be equal to 3. Right? That's what f of x is equal to. It's 3. Or y, whatever you want to think about it that way. So it's approaching 3 from that way. And then from the other way, coming down, approaching from the right. So let's say the limit of f of x as x approaches -6. Now from the right, I'm going to put a little positive sign. It's also going to be equal to 3, right? It's approaching that. It's getting closer and closer to 3. If you could get like tinier and tinier little bits, it's coming up to 3. So that actually brings me to our first thing it has to have to be considered continuous, and that is, so number 1, approach this, 3 from both sides. So this is actually, figured out how to spell, approaching 3 from both sides. And then the next part of that is we'd say, okay, well then, therefore, so if this first part, the limit of f of x as x approaches -6 from the left, and then the red approaches -6 from the right. So if it does that from the left and the right, we can say, therefore, the limit of f of x as x approaches -6, not from the left, not from the right, but as it approaches -6, just in general, is equal to 3. We can make that claim. So that's stipulation number 1 that it has to meet. The other one that it has to meet, so 2, is that, does the point exist? So what I mean by that is if we look back up at our point, does this point actually exist? And it's a filled in circle, so it does exist. So it exists, and it is 3. That's what f of x would be equal to. So we'd say f of -6 is equal to 3. So that's stipulation number 2. It has to meet all 3 of these to be considered continuous. And the third one is written like this. It's written like limit of f of x as x approaches a is equal to f of a. So remember f of a here, this, was really just this, was 3, right? That's what we set up here. F of a was equal to 3. And x, this a down here, is negative 6. So all we're really saying, I think that sometimes gets a little confusing showing it in the proper notation like that, but all we're really saying is that the limit as x approaches negative 6 of f of x is equal to f of negative 6. And it does. This does check out. So what we're saying is that, yes, 3 is equal to 3. We're saying, does 1 and 2 match, really, is all we're saying there. In 1, the limit was equal to 3. In 2, the limit was equal to 3. And then this is really saying, yes, 3 does equal 3. The point matches the limit. I guess you can think about it that way. Let's write that down. Point matches the limit. That's another way of remembering it. Okay, so those are our 3 rules. That's pretty much what this is all based on. And then we're just going to go through and see if all of these things actually do happen. All right, so moving on to the next one here. Let's say, well, first off, all 3 were met there, right? So we say that this was continuous. So this point right here, yes, that's continuous. Now the other ones we're going to check out are this open point. So that's that one. And the asymptotes. So let's do our open point here first. So that's going to be, we'd say the limit, let's figure out part number 1 first. So just do a little 1 there to make sure we know what we're talking about. So let's say, okay, so Thomas just walked in, so I've got 1 student now. Okay, so if we're looking though at point 2, so now we're looking at this point. What we're going to do is go from each side of it again. So we'd say the limit of f of x as x approaches 2 this time. But what we want to do again is say as it approaches 2 and from the left and from the right. So from the left, I'm going to put the little negative symbol up there. And what is it approaching? So not, like I know we can see right now if we look at the point that, you know, that doesn't exist, right? Yeah. But what point is it actually approaching? What if the point did exist, what? Yeah, it's approaching 1, right? So we can say, yeah, it is approaching 1, so that's true. The limit of f of x as x approaches 2 from the right is also going to be equal to 1, right? It's going the other way. It's just going from that side. So then we'd say, well, yeah, so the limit of f of x as x approaches 2, just in general, is also equal to 1. So number 1 is definitely satisfied. The problem here is that number 2, no, number 2 doesn't. So I can't say that that point even exists. F of 2 is undefined. So this is number 2, I guess, if you're going to keep track of what they were. So in that case, all 3 of these aren't actually happening, so not continuous. So this point we would say is not continuous. Okay? Now let's do the asymptote one. So we'll do that over here. So we'd say the limit, just starting again with like point number 1 if we wanted to write that. The limit as x approaches negative 2 from the left would be equal to what?
Infinity?
Yeah, infinity. It's approaching it, like it never does get there, it's approaching infinity. And we also say the limit as x approaches negative 2 from the right. Oh, I forgot f of x up there. F of x is going to be equal to what? What's that?
Infinity.
Yeah?
Negative infinity?
Negative infinity. It's going the other way. It's equal to negative. Oh, that was bad infinity. Negative infinity.
Yeah, that looks like an 8 that got shot.
So yeah. So right off the bat, our stipulation number 1 doesn't even hold up because I can't say that the limit as x approaches -2, not from the left, not from the right, just in general, of f of x, is undefined. I don't know if it's negative infinity or infinity. It's just undefined. So I get stopped right at section number 1 there. I also can't say that, for part 2, I also can't say that that point exists because there is no point. It's negative infinity and infinity, so it doesn't really exist. And point 3, since we never got point 1 or 2, we can't even start.
Doesn't match anywhere.
Okay, Rachel, so we're gonna end that video there just so that it's not like a 15 or 50-minute video.
Thomas was here too.
Thomas is here too, he says.